Hey guys, my name is Carlosity, and welcome back to another video. And today I'm going to be teaching AP Physics 1, Unit 1 Kinematics, more specifically speed versus velocity and acceleration. So let's get started. Okay, so we have speed, right? What is that? Speed is the ratio of distance and time. Speed can be written as S equals distance over time. So speed is a scalar. A scalar is like a quantity that is always positive, like I said here. So you could say 5 meters per second or 5 centimeters per second, or lastly, like, you know, 50 kilometers per hour. So speed is a scalar that is the ratio of distance over time, and it is always positive because it is a scalar. While velocity is the ratio of displacement and time, and can be either negative or positive as it is a vector. So velocity is essentially the same thing as speed, but this time it has a direction that I can go. So you can say 10 meters per second northeast. I kind of do that kind of big. Or negative 10 meters, not negative 50 meters per second. And velocity can be written as, okay, so in physics is usually velocity average, and it is the displacement in like change of position over change in time. So let's say you go from 0 all the way to like 10, right? And you do that in 5 seconds. So based on the displacement formula, right, we replace in 10 minus 0 is just 10. So right here, so let's move this like over here. So you have equals 10, and we're given that 5. Well, this is meters. Okay, remember meters. Okay, so 10 over 5, right? And you get 2 meters per second. Okay, so in physics, the most common like unit for velocity would be meters per second, and for like displacement or distance, it would be meters. So instead of like 5 centimeters, it's going to be 0.05 meters. So just remember that. And yeah, this is 2 meters per second. Alright, let's move on. So in physics, there are two different kinds of velocities. So we have both average velocity, which is total displacement over time, which is the one that we just did, and it is written as V average. Okay, velocity average is the change in position over change in time, or the derivative of position versus time. Well, that's a calculus. But let's just like start with something simple. So imagine you have a graph, and let's say the x-axis is time, while the y-axis is position. Remember, it's always going to be in meters, and time is always in seconds on the test. So we have let's say we start from here, and we just go through here. So this is an object. This is its position at a certain period in time. So it's like 1, and it's like 5, right? This is like 20, and this is like 8. Sorry for the bad handwriting. So this is essentially a position versus time graph, where the position is determined by the time, right? But remember, velocity is the change in x over the change in time, which is also known as the slope. Because look, you change some out of x. It's like the m equals change in y over change in x, but change in x is actually x, but x over here is position. So let's just say like x p, like position, right? So the slope of this graph is change in y over change in x, or like rise over run. So essentially, velocity is displacement over time, right? and it's essentially the slope of this graph. So based on like the equation y equals mx plus b, right? You say that like the x final, x is this. This is like the x position. X is equal to the slope, right? The slope is velocity because we determined that from this. So velocity, x here is time, cause that's what the variable, like an increase in this leads to an increase in that. So vt plus x initial, which is essentially the y-intercept. So like your initial point, and then based on how much time it takes, that's how much more you add. So like imagine you have 50 meters per second, right? And you do that for like 5 seconds. So you were to multiply that 50 by 5, that would give you 250 meters, right? So if you remember like the train track method or like stuff from chemistry where it's like 50 meters, right, over 1 second times 5s over 1, right? You see that the units cancel out, and then you're left with 250, like shown here. All right, let's move on to the. Okay, so let's show some examples of position versus time graphs. Okay, so it's stating the previous one. We have the x and y axis, right? Where the x axis is the time, and the y axis is the position, right? So if you have just a straight line, right, that means that the slope of the line is 0, right? Which means that there's 0 velocity and that the object is not moving. But if we were to have like a line like this, right, that means that the thing is moving because it's changing position as time goes on, which means that it has positive velocity because it's increasing in the positive direction. So usually in physics, the top right quadrant is positive for everything. So this is positive x, positive y, right? But this is negative x, negative y. So anything up here is typically shown as the positive direction. But if the line looks like this, right, that means that the position is changing, but it's gradually increasing how much it changes, which means that there is velocity, but the velocity is also increasing, which means that there's acceleration. And we're going to talk about acceleration real soon. Acceleration. Acceleration is the rate of change of velocity. So acceleration is depicted with the symbol a, and is equal to the change in velocity over change in time. So essentially is that acceleration is velocity final versus velocity initial over time. So acceleration is change of velocity over change of time, essentially. And it is depicted as meters per second squared. Because remember, velocity is already meters per second, but since you're dividing by another time, which is in seconds, you have seconds squared. So if you can see here, so like you have meters per second minus meters per second over second, right? That's just meters per second squared, essentially. Also, acceleration is a vector because it has directions. So you can be like, oh, I'm accelerating. So like you can say, oh, I'm going this way, right? But acceleration is pointing this way. So that would decrease my velocity because remember, acceleration is the change of velocity. You have a negative change of velocity, your velocity is going to go down. In physics 1, constant velocity, constant acceleration will be considered in the course, and that's it. It won't change at all. So this leads us into our. So this brings us to the 3 kinematics equations. Okay, let's start with the first one. So this tells us that the velocity final is based on the velocity initial plus acceleration times time. So you recall y equals mx plus b, right? So you would say that this is y, this is mx, and this is b. So if you were to like draw this on the graph, right? So Vx is on here, and time is on here, right? And the slope of this graph will be equal to the acceleration. So let's say Vx initial. So this is Vx initial. That's what the 0 stands for. If there's like a variable that's like lacking like something in front, that it usually means final. So this is x final minus x initial, but for College Board they don't include the final symbol. So imagine Vxo is like the y-intercept. So we start here. This is the initial velocity, right? And it accelerates for some period of time. So it goes. So based on how much time passed and the acceleration, you were able to find the final velocity. So for example, you say you start. Okay, so we're given that Jim is running at 3 meters per second. He sees a bear and he starts accelerating at a rate of 2 meters per second squared for 5 seconds. How fast is he moving at the end? So we're looking for his final speed, which is Vx, right? We're given his initial speed, which is 3 meters per second, right? So let's say 3 meters per second plus his acceleration times time. So it says he accelerates at 2 meters per second squared. So that's just second times second, right? For 5 seconds. So time is 5 seconds, or 5s, right? These two cancel out. Now you have that Vx equals 3 meters per second plus 10 meters per second, right? You add them two together, and you find that the velocity final that he's running at is 13 meters per second. Okay, for our next one, this might be like one of the most important ones. Well, all three of these are equally important, but this one is like used so much across the course. So essentially, it says that the position final is based on the initial position plus the initial velocity times time plus the 1/2 acceleration times time. But what does that really mean? So remember, change position is x final minus x initial, right? So this equation can be rewritten as change in position equal to velocity initial times time plus 1/2 acceleration t squared. And sometimes the velocity equal to 0, which is this term is equal to 0. And you're either asked to find acceleration or time. And you say that 2 change in x over a square root is equal to time. So let's give an example. It's kind of problem. Okay, so we're given that Ronald Blocks is participating in a race, and he starts at rest at position x initial equals 0. He starts rapidly accelerating at 3 meters per second squared for 4 seconds. And he reaches the final position x. What is x in meters? So based on this equation, we know that x initial equals 0, so we're left with x equals 0 meters plus, let's see, it says that he starts at rest, which means he's not moving at all. So the start velocity is just 0. So it doesn't matter how much time went on here, it's going to be 0 because velocity started at 0. So we're just left with this last term. 1/2 acceleration times time squared. Alright, so let's just start plugging in values. So essentially 1/2 times 3 meters per second squared. So meters times second times, let's see, 4 seconds. So that's 4 squared, that's 16 seconds squared. These terms cancel out. 16 divided by 2 is 8. 8 times 3 is 24. And left that with x equals 24 meters. Alright, so for our last one. Okay, so we're given that Ronald Market sends his rocket into the air from the surface of the Earth with a starting velocity of 20 meters per second. His rocket experiences an acceleration of negative 9.8 meters per second due to gravity. What will his final velocity be when his rocket reaches a height of 10 meters in meters per second? So, we're looking for a velocity final, or velocity squared, I guess. But to just find velocity final, you can square root both sides. So we're just going to look for the square root under all this. So Vx equals that, right? So let's start solving. So we're given that V initial is 20 meters per second. 20 squared is just 400, right? And since we're given that acceleration is negative 9.8 meters per second, we can plug that in. But what is this next term? What is the x minus x initial? Or x minus x initial is change in x, right? But right here it says it reaches a height of 10 meters. It also says that it starts, that he releases the rocket from the surface. So in physics, usually the surface is 0 meters. Anything above that is, like new height. So it's just 10 because x final is 10 while x initial is 0, right? And we just plug everything into a calculator and we solve. Alright, once plugging into the calculator, it gives us that x is equal to, not x, velocity final, my bad, is equal to 14.28 meters per second. Also in physics, sig figs doesn't really matter. As long as you have like 3 to 4, you should be fine. You shouldn't put like 10, it's like 1, 2, 3, 4, 5, 6, whatever. Usually I keep it short and concise. Like put it up to like 3 to 4, but make sure it's like close to what the actual answer should be. Alright guys, that should be the end of the video. I know it's like not the best, but I hope it showed you like some stuff. It showed you how to use the equations, how to plug stuff in, and what like words mean. So like if it says starts from rest, that means that usually velocity initial will equal to 0. If it says from the surface, usually that the height initial is equal to 0. Gravity, acceleration due to gravity is negative 9.8 meters per second. But usually on the AP Physics exam, it's just negative 10 meters per second squared. But I would recommend just using this if you have a calculator. If you don't, just use 10 because it makes it a little bit easier. And remember that this x minus x initial. Okay, x final minus x initial is just changing x. Same thing as this over here. Alright. I hope you guys enjoyed the video and stay tuned for more.